Hello, everybody. This is another cryptocurrency interview in my series of cryptocurrency interviews. Today, my guest is Zach Burns. You want to say hello to everyone, Zach?
Hello.
And Zach actually contacted me because he had been seeing the cryptocurrency interviews and he works on this technology as well. And he wanted to talk about some of the stuff that was involved on his end. And so I'm going to let him actually start off the interview and then I'll be asking questions as we go. So, Zach, thanks for coming on the program today. I'm looking forward to talking with you. And if you could you tell the viewers out there a little bit about yourself and why you were interested in talking about cryptocurrency? Sort of like what's your background in it, and then what it was that you wanted to come on and talk about.
Yeah, sure. Thank you very much, Casey, for having let me take in the time. So I was watching some of the previous interviews, and being a longtime fan of Handmade Hero, I'm a big fan of things like performance and making sure that technologies are in fact provide a good user experience and are just realistic and that kind of thing. And I I saw some questions that may not have been answered, or like some sort of emerging questions that I would like to talk about. And in particular, I want to broaden our horizons about the questions that are being answered or asked rather, about like specific areas in the blockchain space that you might not even know existed unless someone kind of pointed you in that direction. So we'll go over some of those things like very lightly, and they'll give an opportunity to research those things more deeply, in another interview, maybe with someone who is an expert matter on that topic. And in particular, there's 3 points that I want to address today. One is really why a blockchain may be a necessary part of solving the problem of decentralized finance, right? I don't know that, especially to the question of why we need proof of work, for example, or proof of stake or proof of something, right? And the answer seems to be to make things go slow, right? And that is not a desirable property of the system that I feel like we want. So I want to give a more robust answer to that. And then once we've established that blockchain may be necessary, talk about how we can scale the technology, because the promises that are being made, by the crypto community, but then like the needs of the world economy, there's a vast mismatch between those things, right? So we want to kind of bridge that gap in this conversation. And then last, once we've scaled blockchain, talk about innovations that can really only be enabled by having programmable money and e-cash and so on. So kind of like the weird vision of the future that's in some ways already here, and just really surprising and expected things that are coming out of this technology, but that will become more mainstream when we have all this scale.
So could you, though, before we get into that stuff, you had contacted me about this because you actually work on this stuff. So could you also just give people a little bit of an idea of like what, you work at a company that is actually doing stuff in this space. Could you let people know sort of like what your job is, why you were interested in that, and what the company does, just so they have some background? Because of course, a lot of the viewers are coming from my stream are coming at this from the same perspective I am, which is to say, we don't know a lot of the players in the crypto space. There's a ton, right? And sort of getting familiar with like, okay, this person who he's interviewing now, works on this particular stuff, etc.
Sure. So I work at a company called Edge and Node, and it's the mission of Edge and Node to index and serve the world's publicly available data in a decentralized way. So that means, when you go to a website, if that website pulls information that should be public, being able to serve that information to you without relying on a centralized provider who may decide to stop providing that information at any point in time. Also, being able to put the power over that data into the consumer's hands. So maybe being able to pay for those queries. And something that I would hope might come out of that might be to remove the need for advertising on the web, because the user experience of the web has just degraded very painfully, and that's something I'm feeling all the time. And I'd much rather, pay for content than rely on someone to provide it, but then have like ideological warfare going on in order to access this content, right? So that's kind of why I'm in it. My responsibility is a kind of a bridge between the research team and the engineering team. So I just kind of make sure that these different teams are speaking the same language and we're solving the right problems and are able to implement the things that are coming out of research.
All right, excellent. So I wrote down the stuff that you said at the start there, just so I could make sure that we covered the things that you wanted to cover. The first point that you made, I guess I kind of want to give a little bit of a background on, because you specifically said something that is very much a question I've been trying to get answered, and I don't feel like I've really heard an answer to it yet that satisfied me. So if you're prepared to provide one, that would be great. So let me start there and say, yeah, at the outset of this, I've always been very sympathetic to, I guess, what I would call the stated achievement of cryptocurrency that people are looking to get, or blockchain, I should say, which is decentralized access to X, where X is some agreed upon thing like transaction log or like an information store. Reliable decentralized access is great, and reliable decentralized consensus is also great. So I'm pretty on board with the idea, and have never really needed to be sold on that. But what I'm not convinced about is that some of the technologies being offered actually do anything in practice. So, you spoke of proof of work. I'm still not convinced that proof of work actually offers us much beyond just what we would get if we just had a sort of ad hoc consensus mechanism. And I haven't really heard very good explanations of why it is or isn't the case. So if you could start there and say, because it sounds like you have a strong opinion about what technology is necessary at that consensus layer. And could you walk through why you think it is necessary, or if it specifically isn't necessary, what are the properties of a necessary technology there that you think we have to have?
Yes. I'm going to try to avoid getting into specific consensus mechanisms too much, but I'm going to tell you sort of why a decentralized one is necessary and then leave that part open. But so what we talked about before, or what you've talked about before in previous videos, is that we kind of need this consensus around the validity of transactions, and in particular to avoid the double spend problem.
Yes.
They skipped over, though, another important part of this problem, which is creating an ordering for those transactions. Because there's a power that you can capitalize on if you can reorder, insert, or censor transactions. So like a simple example, tying that into double spend, but we'll kind of make more interesting examples after this, is that if A sends B $50, right, and then B sends C and D $25 each, well, we would agree that that's not a double spend, right? A has the $50, they split it up into two pieces and sent two people money. But the order of transactions there actually matters a ton, because if we place that B sends C $25 before the $50 hits their account, then their account would be overdrafted, right? So in being able to order those transactions or insert other transactions after, you can kind of control who gets the money, right? So the question is not really around whether the transactions are valid. It's around the ordering of transactions. So a more interesting example of this.
Can we pause there for a second? Because I think I already have a question. So while I don't disagree that the ordering of transactions is obviously important, if for no other reason than exactly the one you stated, would be sufficient. My understanding was that was usually handled more by the cryptographic signature level. So, for example, in something like Bitcoin, my understanding was that transactions themselves, of course, are signatures on a piece of Bitcoin. So the signature has implicit in it already signed the previous person who handed over that crypto to them. So you could never really get in a situation where someone could reorder a transaction because the transaction itself sort of says what the previous transaction was. In Bitcoin, anyway. Does that make sense?
That does make sense. I don't know if that's how that actually works or not. I'm not an expert in Bitcoin. I usually think a lot more about Ethereum.
Okay.
But in Ethereum, that's not really the case because we have programmable money.
Okay. Yeah.
And so there's not necessarily even a concept of where a transaction actually came from. It's just data. And so when I get into the other examples, this might make a little bit more sense.
So if you could construct an example, then, or I mean, let's put it this way. I am quite confident that at least in the case where you use transactions that way, which Bitcoin does, or at least, I mean, I don't consider myself an expert on cryptocurrency, so maybe I shouldn't say that. But would we say that if cryptocurrency was signed that way, meaning if the transactions themselves include either a nonce or a reference to the previous person's public key, or who knows what, not public key, it would have to be, I guess, a privately signed thing. But either way, assuming that the transactions have something that allows you to order them cryptographically, then we don't really need that for this purpose. Is there another purpose that you would need it for, or is it only the case that you need it when you are doing something like Ethereum where you don't really have that concept of transactions involved?
So I don't think that you can actually reliably do this with any system without also guaranteeing ordering. I can go back and look at the Bitcoin system, but even if the transaction included something that said where the funds came from, but the transaction that sent those funds was censored by the chain, then those funds would not be sent, right? That transaction would be invalid.
Yeah, I mean, you would lead to a detectable error, meaning it would be everyone would know that someone was censoring, but they are still censoring, I guess, or something. But anyway.
Sure.
Yeah, I mean, in other words,
interesting examples, though.
Yeah.
Sorry, are like arbitrage.
Okay.
So arbitrage is when you're able to buy low on one market and then sell high on another, right? And so with Ethereum, we don't just have transactions, we have programmable money, which means there's things that exist there like automated market makers, where you can do essentially like have an exchange that exists on chain in an automated fashion, right? So you can do essentially the same thing that like a high frequency trader would do by observing what's going on and finding opportunities for arbitrage, being able to buy low in one market and sell high in another, and insert or reorder transactions as you see fit, right? And so the ability to do that is extremely powerful, right? So just this year so far, there's been $700 million of value extracted by miners using arbitrage, right? And so given this set of valid transactions, which anyone could say that all the transactions are valid, still like knowing what order that they go in has an enormous impact on the outcome. So all that we really need to do is establish a consensus on the order. And if you say, here's the valid block and it has all these valid transactions in this order, and someone else says, here's a valid block and they have all the transactions in a different order, then the question is, well, which one is the canonical version of the chain?
Okay. Continue.
Continue. Okay. So if the problem, right, is establishing the order of the transactions, right, and then I kind of switch and put my engineering hat on for a second. A transaction is just data, right, which has a representation in bytes. So if you have like a total order of serialized values over time, that's a byte stream. And if you take a byte stream and chunk it up and add consensus to it, whether you like it or not, the thing that you just created is going to be called a blockchain, right? Because you have this ordering of bytes, and we're adding consensus to be able to progress this sequence of bytes over time. And there's kind of no way around it, right? If you want to establish consensus around an ordering of bytes, you have a blockchain, right?
So I guess there's two parts about that, though. One is that blockchain is separate from consensus algorithms. So, in other words, you could imagine building something that was a append-only ledger that had a consensus protocol that does not itself do things like use proof of work, for example, right? Which gets back to my original point of like, I don't disagree that having a distributed consensus protocol is good. The question is this, or are the ones being proposed good ones or bad ones, right? So I guess one question I would have is, do you have an opinion on that? Or are you just like, no, I don't really care as much about that part of it, and maybe I don't even like proof of work or something. I just say we need to have some kind of blockchain, which is a much, obviously that's a much different statement than I think we need proof of work, or I think we need proof of stake, or I think we need proof of space, or any of these other things. So there's that one.
I think honestly,
Go ahead.
Yeah, go ahead.
I was gonna say the
I
other.
think honestly,
No, okay, go. Sorry.
Most people in this space, I think, would accept any system with certain properties, right? And that is that it enables distributed consensus around the byte stream, which is sort of a necessary property for one of the things, all the things that we're about to build on top of this. And that power be distributed in a way which has legitimacy. And does not end up being controlled by a centralized actor. So from a pure efficiency standpoint, I'm a big fan of proof of stake. There are proponents for proof of work as well. I think they end up being kind of the same thing in the end, because either like you're buying stake with money or you're buying electricity with money. And so when you want to get into questions around like concentration of power and what's going to happen between the two systems, I think they tend the ssame way. And we might as well not burn electricity then. So I like proof of stake. But this is not actually my area of expertise. I want to kind of get into like, once establishing that this is necessary, how do we even scale this thing, and then build interesting stuff on top of it?
So basically, you would say you don't actually really want to make an argument about whether or not any particular consensus algorithm is useful or not. You just want to say, look, we need some consensus algorithm, and I'm happy to let other people solve that. In which case, yeah, we should totally move on, because there will be people, I'm sure, who I interview who want to argue for one or the other, who I can ask about those parts. All right, so
Sure.
let's just say that in general, I would agree that having a consensus on what the ledger looks like is probably useful for a number of applications. So I don't know that I really have that many questions about that. I'm not sure I'm convinced about the arbitrage example, but I think I could come up with my own examples about why I would want to know, even if I, for example, introduced a canonical ordering, meaning that transactions, for example, had their hashes, whatever their hashes were or something like this, produced the ordering or anything like this, I could still see why you would end up in problems of like, well, okay, but you still have to choose which transactions are going to be in a particular block, because you get more transactions every time than can fit in the block. And if you get some transactions later than I get some transactions, or I'm a bad actor and I want to try and stick specific transactions and move other transactions to the subsequent block, I can see why we need some kind of a scheme to produce a consensus about which transactions go in the block. So I would say I'm roughly with you on the fact that we need some kind of consensus algorithm. And let's just say in this interview, we're not going to talk about what it is. You want to talk about scaling. One interesting thing about that is that sort of implicates the consensus protocol potentially, but I'll let you start by just saying, what did you want to talk about with scaling? Because maybe it doesn't implicate the consensus protocol.
Sure. So the questions that then naturally emerge, right, if we are trying to get consensus around a total ordering of bytes, is, well, does all of the data that we need require a total ordering? Or can sometimes you have a partial ordering and use like CRDTs, which are conflict-free replicated data types? Or right, can you use partial ordering sometimes and have dependencies resolved? Do we need to keep all of the history forever? Does all of the data need to be public, or can some of that data be private? Can we compress the data better? Can we split up the consensus problem to let independent data streams and compute progress simultaneously and then sort of synchronize those streams together? Can we innovate on the actual cryptography that's being used under the hood to do more with less? And can we think in a more data oriented and cache coherent way in general? These are all questions that have different answers depending on the actual problem that you're trying to solve. But depending on how you're, like, if you take into account the specific information about your problem, then you can take advantage of different areas of these optimizations, and they'll lead to different scaling solutions, which end up being composable. So referencing, for example, non-pessimization, the base case for the maximum code reuse is to use the blockchain for everything because you're lazy, and that will just always work with the minimum effort, and you don't have to consider what the implication of any of those questions are. But then, right, if you want to really take things to the next level, you have to start to think about these questions hard and use different scaling technologies as appropriate. Because at some point, what you're going to need at the very bottom is something whose sole purpose is to orchestrate the synchronization of all the stuff that's happening on top, which would otherwise end up with ambiguities. And that might be all that exists on the bottom, is something that just provides atomicity and the synchronization for data. But it's still going to be called a blockchain, unfortunately. Negative connotations come with that. And then it's necessarily true that the blockchain becomes a part of the solution, right, if you want to be decentralized. So before I get into like specific scaling technologies, I want to ask you, what do you think are good targets for latency and throughput, such that if I said, here is the system, that you would then accept that as like a worthwhile contribution to the economy?
So I guess it's probably not worth asking me specifically what I think the targets are, because if I had to say this early on, if I had to say what my concerns about crypto are, they actually aren't that. So most people talk about like the latency or the throughput of transaction models as being something that they're concerned about, and there's a lot of talk in the crypto space about that. That's actually like the least of my concerns. My assumption is that if that was my only concern, that either someone else will solve that problem or I could go solve that problem. It just doesn't sound very scary to me. My concerns have literally nothing to do with that. I would say currently the two primary concerns I have is that the design of current cryptocurrency systems, to me, doesn't sound like it makes any sense in the broader picture. So I don't know that it's worth getting into, but I would say the two that I have are, number one, I would say the two generals problem is the most important problem here, and no one has any idea how to solve it because you can't really, which is to say, I bought something with blockchain and they didn't deliver the good or services. People tell me all the time, no, we solved that by X. And I'm like, no, you didn't, because it's mathematically impossible to solve it. So tell me what we do after that. And I haven't heard an answer there that actually satisfied me, because they all, to me, lead back to, we're back to the government being mostly involved, and at which point they can regulate this and do whatever they want, which to me eliminates some of the benefit. So that's problem number one. Problem number two is the design of it is not decoupled. So the example I usually give is like, okay, so, this is supposed to be the future of currency. Well, how does the Mars colony reach a consensus with us if their transmission time is this far away? How does the one that's further out than that? It's like, it seems to me like the future of currency should be one that deals with disconnected subgraphs and reconciliation over time. So I would start with a base layer that did that, not start with a base layer that was consensus-based, especially because, at least if you look at current world economies, that's not how they work anyway. We don't all, the people, agree on the value of money at once, and that's a strength, not a weakness. People spin it as a weakness, but I disagree. So I would say those are the things I think about in crypto. Most people I've talked to so far aren't really ready to talk about those things. I do have people coming down the pipe who hopefully will be interested in talking about those things. But if you want to talk about them, great. If you don't, I'd say just put them to the side and talk about what you want to talk about. But that's my actual answer, is that throughput and latency just doesn't really scare me that much, because that's an engineering problem I feel like I could work on it, right?
Okay, interesting. Because a lot of the objections that I hear about crypto are actually in the throughput and latency category. So I'm prepared to talk about that a lot,
Yes.
but I would like to talk about the two generals problem and the decoupling a little bit.
Okay.
So you're absolutely right that the two generals problems can't be solved, right? Like no one's going to convince you otherwise
Yes.
because it's mathematically proven fact.
Yeah.
And so if I want to buy a coffee with crypto, then there's going to be no way to really convince anyone that in fact you've delivered the coffee and maybe they drank it, maybe they didn't. I don't know, right?
Yes, it's a real
Um,
world observable event, so we just have that problem. There's nothing you can do.
right. However, it's a problem that we have today anyway. And so like if we imagined that we had a world based on electronic cash and then we were saying, well, should we switch to the paper cash, and people were asking me, well, we shouldn't do that because the two generals problem. I would say, well, okay, well, either neither system is ever going to solve that problem. So why is it even a question about which one is superior? Maybe we don't have to actually solve that problem to offer a substantial benefit. That's part one. And part two is that with smart contracts, at least for digital goods, you can actually solve the two generals problem by making receiving the asset contingent on paying for it. And there are an increasing amount of digital goods that actually have value in the real world by way of legitimacy, even if there's not like a real concrete link between the real world and the crypto world.
Yeah, so I guess what I'd say is I disagree on both parts of that. So the first part of that is that, sure, yes, every currency system has this problem. But the point is, the real world currency system has a solution to this problem, which is, courts, a legal system, police. And you can't, my argument is you cannot get rid of this because of the two generals problem. You need a adjudication process, and that adjudication process is necessarily subjective. Because of that, my argument is that just means the proof of work stuff, the we need distributed consensus, all that stuff to me just doesn't make sense because we already need police power to enforce the transactional integrity of the system because we can't do it without that. So why do we need all of this proof of work stuff? The government will already have the ability to police our transactions because without that ability, the transactions themselves won't have integrity. So once we say that, why not just give up? What does this actually bring to the table, right? And again, I have not heard anyone actually answer this question other than the closest person was Amaury Sachet to actually engage with the question, and he basically said, kind of a very loose idea that maybe just if enough people are using it, the cross-boundary nature would at least pit governments against themselves. But, those are wishful thinking. I mean, it might happen, but it might not. So it's not a very good technical argument at some level, right? So I would say that's for part one. For part two, I would again disagree. People often say that, okay, well, with a smart contract or with, some kind of an enforcement mechanism that says if I didn't put the money in, then, you don't get the download or whatever. But it really can't do that because any transaction, even a digital transaction, is not based on some binary representation of something. What it's based on is what the two parties thought they were getting out of this transaction. And so if somebody represents to you that this particular piece of software does something, well, if the way that I get access to it is by buying it on the blockchain, and the blockchain does guarantee that I get access to the software, but then I find out the software doesn't do the thing you told me it did, well, that didn't solve the problem. And if I could use the software ahead of time, then I didn't need the blockchain to get it. So I would argue there's no solution to the two generals problem in either case. And the fact that most people think that there is a solution in either case is one of the troubling things because those two things I just said should have been obvious to anyone working in this space. So it definitely raises my suspicion level that people haven't talked it through, that complete analyses of those problems are not easy to find and abundant. Does that make sense?
It does. I don't think that all exchanges of value are necessarily subject to that problem. So for example, what we do at the Graph is we enable the decentralized indexing and querying. So we can actually show we actually have like court systems that exist on chain to show whether or not, if you make a query, that the results from that query is the one that's under consensus by the broader group, right? And so the entire judicial system really does exist on chain. It's kind of in its infancy right now, but you can scale it up to things like refereed games, which would be able to actually run the computation and in an efficient way on chain that bisects that computation so that people can disagree about portions of it until you get down to a single instruction and then execute that instruction on chain. So I can, for example, run a query against data and then show the consumer that the result of that query is correct, either from arbitration, which is the early stage version of this, or fraud proofs, or then go into verifiable queries, which would be like the highest level of this, where I give you a mathematical proof that the result of the data is in fact correct. And then you pay for that data in exchange for having received that proof.
Which, I mean, like I said, I can appreciate that there are some very select cases where it is digitally possible to guarantee that the transaction took place, but that is just simply not the majority of all consumer transactions, right? Which, I mean, presumably we would agree that the normal human being who is just going about their daily business, who wanted to purchase, the latest Justin Bieber album, is not really going to be employing any kind of mathematical proofs about what they were expecting. Either they expected there to be 12 songs on the thing or they didn't, and the likelihood that we're actually going to have digital models for guaranteeing things that people perceived about a contract into which they were entering is just, I mean, while somebody could make the argument to me, it would take a long time. Like that the average person will actually be engaging primarily in digitally verifiable transactions, I think is a very hard argument to make. While I would not disagree that there are some. And it could be that, enabling those some is good, and that's totally fine, as long as people are upfront about it, which is like, okay, this will digitally verify a very small percentage of the transactions, but those are important transactions to us, so we care. We admit that 90% of the transactions simply are not verifiable and will have to go through the court system is a very different statement, right?
Mm-hmm. I tend to agree. So I'm not going to come at this from the sort of cypherpunk angle. Right. I think a lot of people already do that, and there are interesting people who think about this problem a lot. I live in the United States. It's a fairly privileged, place where I tend to think that at least given the impact that they've had on my life, that regulation and government having some level of control over finances has generally had a positive impact on my life. I don't know. I mean, there's definitely a bunch of shady stuff that goes on behind the scenes as well. So I'm not really taking it from that angle, but I think that there's an entire set of new use cases that will become enabled through digital currency specifically, like verifiable indexing and data and that kind of thing.
And so, and I don't necessarily disagree, right? Like to moving things online is not necessarily bad either, meaning, really more what I'm worried about is the lack of recognition that these things would be necessary. So it's like, another answer, at least to me, would be, well, we're just going to move this stuff online, right? It's like, so for example, you could imagine a digital currency proposal where they were like, we're going to have it be subjective. And it's got a court system built in, and that court system is subjective. And it's got jury selection built in, and that jury is randomly picked from the pool, right? I'd be like, yeah, that sounds plausible to me, right? So again, I also don't want to suggest that I don't believe there's a future where everything takes place in some kind of decentralized system. It's more that I'm not convinced that the ones people are talking about solve those problems. So, not that this is relevant either to what you want to talk about, but say while we're on that topic, I don't disagree that we might have a digital future. I just am not sure that things like consensus over the blockchain needing to require things like proof of work actually makes that much sense to me, because I'm wondering whether it really buys us that much. We don't have to belabor that point anyway, because I know you want to talk about scaling. So, we talked about the two general stuff. Unless there's something else you want to say about that, we can just put that aside and move on to scaling. But if there's more you want to talk about, feel free.
If you want to revisit that question, let's do so sort of after we've talked about innovations enabled by programmable money.
Great. Yes.
Because I think
perfect.
That use case is actually so compelling that even if we never solved the two generals problem, or court systems and whatever, we would still end up with a pretty interesting case for using this technology.
Okay, great. Then just go forward with the scaling part that you wanted to talk about, and I'll revisit it if it comes up at the right. I'll pounce on it.
Sure. All right. So starting with setting sort of the expectations of where we are today, I want to make sort of a comparison to the different ways that a user can do value transfer, and I think you're already pretty much on the same page about this, but just like to recap for the audience and everyone. So the user experience for this is absolutely terrible, right? Even in the United States, where supposedly we have pretty good banking, right? Your options are like cash, which requires physical co-location with the other entity.
Yes.
We have checks, right? Checks have no answer to the double spend problem at all.
Yes.
And wire transfers is sort of like the closest thing to eCash.
Yes.
But they require me to physically walk into my bank, pay a $25 fee to send, and then again $25 to receive one.
Yes, yes.
And take like a long time to settle. So
to be fair, I would point out though that is a U.S. problem. So in Europe, there are many countries that have like trivial bank transfers that actually work really well. But I take the point and am on the same page, because it's like, well, okay, but banks in the U.S. don't want to do it. So, if crypto's a way to force them to do it, that's fine with me too. So either way, I take the point that even in countries that are supposedly developed, you end up in situations where banks might just suck.
Right. So the case that I want to make is maybe we can even just replace one of those use cases, like wire transfers. Then this would be a small but meaningful win. And I think we're actually already almost there. And we can go way farther. But before we do, I just kind of want to acknowledge the value of the progress that's already been made. So we looked at some statistics yesterday, and Fedwire, which runs the US wire resolving system, they processed about 770,000 wires daily on average for August 2021. So they're not open 24 hours a day, which is another problem with the wire system, but I digress. That would be a throughput of only 9 TPS on average, 9 transactions per second on average.
Okay.
At peak times, right, you would require higher than that, right? But it's not a lot. A latency of hours to days, a cost of $50 per transaction, and the physical trip to the bank. Ethereum, on the other hand, currently has about 14 transactions per second, which is up from the 9 used by Fedwire. You can send it from home 24 hours a day, 7 days a week, globally. It has variable latency depending on what security margins that you want, all for the low price of about $10, right? So if we want to ask the question of whether or not it's a useful contribution to society, I'd say, well, yeah, it's great because it's better than wire transfers in throughput, latency, price, and convenience, right? And I'm going to call that a win, even if we're not going to set the bar at save the world just yet. Maybe we can kind of acknowledge that something useful has already been accomplished, right? And at Edge and Node, where I work,
well, I mean, if I could interrupt though on that, I don't know that I would agree on that. I mean, those are useful statistics to be sure, but one of the problems with looking at a statistic like that is that it's not really comparing apples to oranges. If you look at something like a Fedwire, it's an established transfer of money that actually has a number of things to account for that Ethereum, for example, doesn't provide. So baked into a Fedwire are all of the things that the government has ever wanted to have out of the system, they got. Insurance, knowledge of who the transfer parties were, banking regulations for how much capital they have to have on hand, et cetera, et cetera, et cetera. So when we talk about Ethereum, it's like saying, well, if you give up literally all of the protections of the US banking system entirely, we get slightly better stats. And it's like, okay, that's not very good, actually. So in my mind, when I look at that difference, I say that's terrible. If you were to give up all of the things that you get with the US banking system, and all you got was that improvement in stats, I would say that's a massive failure, because you should have been way better than that if you didn't have to do anything, like provide these guarantees, or like all you did was reach consensus on an integer, but you didn't provide any of the other things. Does it make sense why that's not very compelling from someone like me, who's like more of a realist about what does this do in the actual like real world at the limit?
Yep, I totally agree with that analysis. Although, I mean, I think some people would actually prefer to live without the regulation. I'm not necessarily one of those people. Although,
Yes,
again, it's not
yes.
something I really consider that much. But I do know, like, some people actually do care about this. We have a globally distributed team, and some members of this team are compensated in crypto today, and right, do this because it is useful for them to do so. They don't necessarily have reliable banking systems in their country, and that this is just what they need to do to be able to work on our team.
Yes, definitely. And one of the things that is nice about crypto already, from what I've seen, I've actually got someone who agreed to talk to me next week about this very topic, which is just like, one thing I do agree would be true just in general is it seems like if you have an existing system like the US and you have Bitcoin as like a sub-currency or some other thing as a sub-currency, it does seem very good as a means of sort of clandestinely extending your financial system out into a region where like the government there doesn't want you to, or other things like that. That does seem to be a very compelling use case. So I would readily agree that seems to already be happening. Whether it's too much of a problem with illicit transactions as a result, that's a whole nother discussion. But no one can argue, I think, at this point that it isn't happening. Meaning it's like a blockade running device at the very least.
Sure. Yeah, that is a useful take. Although I still think the picture is a bit incomplete. And then I'm one for adding more rules, not less, but be able to express those rules in a way that's automated and composable, and so that we can build kind of interesting things by taking advantage of those rules, like having arbitration exist on chain and having all this other, like, the reasons that those rules exist. Many of them can actually go away and can be encoded using economical models that are actually deployed on chain, and you kind of create like opt-in governments, so to speak.
Right.
But again, we're getting ahead of ourselves a little bit.
All right. So scaling.
So the first thing that we would need to do to scale, I think, is just actually non-pessimized optimizations, right? This answers the question of where would we be if we just tried like a little bit harder for the technologies today, which I'm going to argue are terrible.
Okay.
So taking the EVM specifically, which stands for Ethereum Virtual Machine.
Yes.
It has a word size of 256 bits.
Okay.
Which is a lot larger than that of a CPU, which would normally be like 64 bits, right? And many of the standard protocols and operations and the serialization, et cetera, they all like rely on this word size of 256 bits. So even if you want to store a bool in Ethereum, right, that's a 255-to-1 ratio of wasted space compared to the optimal way that you might want to store something. And if you think that's bad, it's going to get a lot worse. You look at how the EVM handles storage, for example. They essentially do cryptographically strong hashes to determine the address of data, and then store all the values that those addresses point to, like in the leaf nodes of a Merkle tree, and then like propagate all that state up to the root of the Merkle tree using again cryptographically strong hashes. So even an array works this way. So instead of having an array of contiguous data, which would be efficient to fetch and be cache coherent and iterate over, an array is a mapping under the hood with cryptographically strong hash keys serving as the addresses tree to values. So from that standpoint, it's literally the worst case imaginable. There's data scattered everywhere, and then there's like dependencies that make it so that you can't do any pipelining. And when I saw JavaScript, I thought it was bad, but the EVM kind of like puts this totally to shame. And I'm not making a great case for the tech, right? But that's kind of the point. Because if everything was actually optimized today, then it would be hard to make a case that we could in fact scale the technology, right? But right now everything is implemented in like the worst way imaginable.
Right.
I mean, it doesn't always have to remain that way. There are reasons that the things that I described exist, but as our cryptography improves and we use better techniques and these things gain popularity, I think a lot of that is addressable, right? So that's a potential gain number one, is switch to a non-pessimized backend and execution engine and just sort of establish norms of non-pessimization across the blockchain space. I would say that things are generally getting better here as people are acknowledging that we have a problem, but a lot of the problems that we do have persist just due to the sheer momentum and network effects of being able to use the things that exist rather than starting over from scratch, right? So there's a culture problem. For predictions about the potential gains, I don't have any hard numbers, but given like the facts of our shared experience optimizing code and the situation I just described, I'd hope you'd not be too skeptical of the rough hand-wavy guess that it's going to be like 100x or some ridiculous number of what's possible to achieve just by using a better backend. All right, so that's optimization number one. Do you have any questions about that, or are we ready to go into part two?
I don't think I have any questions about that in particular, because I mean, what you're talking about there is strictly applicable to smart contracts, or rather things. Smart contracts is kind of a dumb name for it, I suppose, but on blockchain verifiable execution. Specifically Ethereum, I don't know how many other people have taken a crack at making a VM and whether they made better VMs, but that assumes that you want a VM in the first place, which I think we may be putting the cart before the horse a little bit here, because I guess the third thing you wanted to talk about was why we need these things. Can I convince you to put these in the opposite order? Because I'm not sure we need these VMs in the first place. So maybe if you could start with the innovation part and explain why we need a VM at all for this consensus protocol. Could we just not have one and trust that people are running their own VMs on sub-services if that's something that you want, and we know that everything's reconciled through a consensus algorithm at the end, and that's all we really care about, or things like that? What's the high-level pitch for why we need the actual root blockchain technology to have a specified VM baked into it?
Yeah, I think that it makes sense to reorder kind of what we talked about, because why build something if you don't need it?
Yeah, I don't need to optimize it if I don't need it, right? The most efficient way to run a VM on the blockchain is to not run one. So let's talk about why we need to run one, right?
Yeah. So what I've observed is that, like MRA said when he was on, that things are going to get weird in
yes.
ways that we can't imagine.
Yeah.
And that we can't anticipate. In the space that I've been working on, I've been seeing this all happen a lot. And so I'm actually seeing concrete examples of things that I don't understand and are composable and I cannot predict the effects of.
Okay.
But I think that they're interesting and worth exploring, and it's going to be hard to fully explore them without actually scaling.
Okay.
So I'm just going to run through some weird examples. Some of them may be like laughable and weird. Some of them might be kind of compelling. Some of them, might be, just way out of left field. But at least I want to surprise you.
Yes.
And then kind of like spark the imagination to see how you might imagine that more things are going to come out of this system.
Great. Yes. Perfect.
So number one thing that was pretty surprising to me that I encountered on Ethereum is something called a flash loan. Have you heard of this concept? I can explain it for the benefit of everyone anyway.
Yeah, even if
But
I had heard of it, please do. But no, I have not heard of a flash loan. At least I don't think I have. There's a lot of terminology, and so it may have gone in and out. But
a flash loan is enabled by smart contracts. Essentially, what you do is you deploy a smart contract that has custody of the funds. For some reason, you're using these funds for something else, but you enable a flash loan by having a contract call that you provide a callback to, and will say, I'm going to give you all this money. Then I'm going to call your function that you gave me. And at the end of calling that function, I'm going to check and see, do I have my money back or not? And if I do, then fine. But if you haven't paid me back, then I'm going to revert to the transaction. I'm just going to throw an error, and your transaction is going to fail. So I get my money back, and the thing that you wanted to happen didn't happen. So what this means is that you can loan out to basically anyone tens of millions of dollars without a credit score for an instant in time. And I don't think that there are necessarily any good applications of this, but it is really weird.
I'm not sure I understand how that even works, because, I mean, I suppose I don't need to know the answer to this question, but I'll just ask it anyway because it's what occurred to me. So in Ethereum, assuming that's what you were talking about, because you were talking about Ethereum before, you need to pay per VM instruction, if I remember correctly. This is the gas concept. I need to pay for it.
Yep.
So where does the gas come from?
The gas. Well, so we didn't actually talk about gas, but gas, there's a fixed limit of gas in the block. But what you're loaning out is not necessarily gas. It's some other underlying asset.
Right. I meant who pays for that. The person who asks for the flash loan gives you the gas to run as well, I assume?
They actually give the gas to the miner. The person who is giving the flash loan doesn't actually even really participate in this. So they deployed a smart contract, they have funds in it, but they don't need to then interact after that. So the person who is asking for the flash loan, they make a call and they say, I'm going to pay for this call. And so the miner then will run that call and tally up the gas and make sure that it doesn't go over. When you make a transaction on Ethereum, you give a limit to the amount of gas that you're willing to spend for that transaction to run, as well as a price for the gas that you're willing to pay the miner in ETH. And that's sort of underlying the security assumptions of Ethereum, is in being able to pay miners these fees.
Right. Okay. So the person who wants the flash loan basically executes the transaction by providing all of the gas that presumably the function that they're going to call is one that they have analyzed, so they know how much gas they need to provide. They provide the gas, they target the flash loan address. The Ethereum VM, then whichever miner is going to execute this transaction, actually does that and takes the gas, does the transaction, and as part of that transaction, in the code for the flash loan, it basically has an atomic section that says, we're going to start here, do all this stuff, and if my balance would be below what it started when I end, then revert. If it's above or equal, remain. Got it? I basically have
Correct.
it right? Okay. Yes. Go ahead.
Yep. So that's a thing that you can only really do with programmable money. It's kind of a silly thing.
Yeah.
Its practical applications are actually mostly security hazards.
It would seem.
You don't really want $40 million showing up your smart contract store at a moment's notice, but it is interesting. So another thing that exists on smart contracts is like an automated market maker, and so basically you can provide liquidity pools and be able to buy and sell into these liquidity pools with assets of any kind, basically, without really involving a third party to do the exchange for you. And so basically someone just looked at an economics paper, they said, hey, you could build this thing. And then some guy out of their garage or whatever built an actual exchange that is now deployed. And so with that particular example, something that's interesting here is if you wanted there to exist an automated market maker and there wasn't one before, if someone built it in their garage and were like serving that data out of a server that they were running from home or something, you would be really wise not to use that thing. But by having deployed the thing on blockchain, what happens is that an app then has transformed into a platform where people can basically rely on that automated market maker to continue working in the future, regardless of what happens to the person who created it initially. They can get hit by a bus or whatever. But by being able to then rely on that thing having been deployed as a platform, basically in perpetuity, you can now build on top of that. So a real world corollary of the hazards that can exist if you don't have this transformation from app into platform is something like Twitter. A couple years ago, they had a streaming API, which used to make certain data available, and entire businesses formed around analyzing this data from the streaming API and providing this data to different consumers. And one day, Twitter just kind of shut it off, right? And those businesses all went under because they really had no other business model that existed. However, if the things that they were building their business model around could be assured to exist, and if they exist, like if data and code exist together as a platform, then it allows us to have more confidence in sort of composing all of these different pieces together.
I guess I don't.
Does that make sense?
No, it doesn't. So let me. Okay. And this may just be because you have to. You have to also appreciate the fact that I so far have been talking to mostly people who are Bitcoin experts, not Ethereum experts. So I haven't had a chance to really interview anyone yet who wants to talk in depth about things like Ethereum architecture or any VM architecture. So you're getting the first wave of my questions, so I apologize for that. But
totally fine.
I actually no, I don't understand that concept. So let me ask where I don't understand it. So I'll start with a simple question, which is I'm whoever this person is in the garage. I've built this market making system, and what you're basically saying is I have encoded the market making system. I would assume entirely, or at least substantially, for all the important features in the VM of Ethereum, correct? In my garage, I typed in this NASDAQ, but in the Ethereum VM. That's where we're starting from?
Yeah, and actually, I can send you a link later of exactly how that thing works.
Yes.
These are real things. They're in fact deployed, and you can just read about how might you build something like that.
Well, I kind of have an idea how you'd build it because I read the Ethereum paper, so I saw how you did. Well, it's called the yellow paper. I don't know. I think it's called the yellow. Was that the yellow document? Something like that. There was one that had the whole VM listing in it, and like here's all the instructions. So I was like, I vaguely get what you would do. So assuming that I did that, and I code that into the Ethereum blockchain, now that is on the blockchain, and people are targeting addresses, calls into that system they want to do a transaction to like put in or withdraw something from that system. They're calling functions that are addresses in the Ethereum VM effectively of functions that I've written and that are stored there, correct?
Yes. So your contract has, as you know, code is data, and data is data too, right? Storage is also data. So when you deploy code to Ethereum, that code lives as data. All of you can make public and private APIs, which would have access to storage that's local to that contract, right? So no one can go in and just like rewrite the storage, but you can provide APIs that access that storage or manipulate it in particular ways of your choosing. And then that just lives, right? So a contract, like a real person, can actually be the owner of assets. So if the contract wants to transfer assets, then it can do that. And you can transfer your assets into the contract and then compose assets in interesting ways.
And so since I assumed that was the case, here is the actual, well, there's a multi-part question. Part one of the question is, there is a bug in the system. How is it fixed?
It's not. And so, and there are some high profile examples of there being bugs in these kind of systems. And then when people discover them, they yank the money out, and then people's money is gone, and that sucks. So what I would say to that, though, is that the real world exhibits this problem too, where if you want to choose an exchange in the real world, you'll spend some time maybe researching the reputation of these exchanges. You'll then trust them with your assets. And in many cases in the real world, people in fact do pull the money and run, right? The difference between the blockchain and the real world system is that in the real world system, humans are always involved. So we're not really approaching a better system. But with the smart contract, a bug can get fixed. And the longer that a smart contract lives, with the more sort of assets that it's managing, so the more trust that you can have. And you can, in fact, go and review the code and see if it's simple enough that you can really understand it and make sure that you think that there's no bad thing happening. As we're patching bugs in these things that are deployed on chain, we're actually asymptotically approaching a robust system that we would never be able to achieve just using the real world corollaries.
Right. So actually, I guess I heard two different answers to the question. The second one was the one I assumed was the answer. So let me just clarify. When I said there's a bug, how is it fixed? You said it's not, but it sounds like it is, meaning it's patched. So that's what I was trying to get at. So explain the process of how a bug is fixed in the code when it is found. I'm not talking about recovering from somebody exploiting a bug. I agree that is a problem, but it's a problem that you have with any digital system. So I wouldn't necessarily call that a problem with Ethereum VM. It might weaken some of the claims people make about Ethereum VMs for sure, because they may be trying to oversell it, but it's not like, I mean, whatever, right? So I'm talking more about, okay, so we find a bug, a very critical security bug, we think, and we need to fix this exchange. What happens?
It kind of depends. So what I said before, that you don't fix the bug, what I mean is that you can't sort of you can't like replace the fact that smart contract exists. You kind of can, but I'll work toward it. The trivial thing that you can do is just deploy a new version of the smart contract, and that would actually just be a different smart contract. So if people wanted to continue using that system in the future, they would have to migrate their assets to the new version of the smart contract. And the experience of that is not great, but at least then you have the new version that exists. The fancier version of that is that your smart contract is actually just a proxy, and it calls some underlying smart contract under the hood, excuse me. And due to some governance process, which there are many ways to create and compose, and we can kind of get into governance, enables you to change the smart contract that the proxy contract actually points to when it calls functions. So it will sort of provide access to its data, and then it will allow you to upgrade the code by pushing the version that way. Does that make sense?
It does. Is that what you would imagine to be the correct way to deploy on the blockchain for the benefits that you're talking about?
Yes, if you have a sort of a reasonably legitimate governance model that people are going to buy into. And so that's a lot of the question, right? Is how do people define legitimacy? Like how much control is too much control? Is it a centralized control? So for the graph, we did in fact use this proxy model where the smart contract doesn't really have like total access to your funds unless you're actively using them in the protocol. But you can use funds sort of you can transfer assets around even without interacting with our smart contracts. So there's no way for us to like hot patch the smart contract that would just take funds from users, for example. And then we distributed governance among a group of 10 people called the council, and they exist to represent different views from the community for different parts of the protocol. So like we have 2 council members for indexers, for example, and 2 council members for curators, and just different roles. So we took that control that we had over the graph at one point at the initial distribution and just gave that control away to the community. And that's a way of doing governance, but there's other ways too. And like getting back to the composability part of it, if you say, here's an address that is what my smart contract is pointing to, then you can actually take the control of that and say, I'm going to now mint an NFT, and I'm going to take that NFT and I'm going to make that NFT, like whoever owns this NFT, be the person who can patch the contract. And then because that's composable, right? They can say, well, I'm now going to sell this NFT on some exchange or run an auction or whatever. They can do whatever they want with it. Or maybe they deposit that NFT into something called a DAO. And a DAO is basically just a decentralized governance model where people can vote on it. So they can take that NFT, they can fractionalize it, and give that the control of that NFT to different people, so that people can vote on what happens. And so that if everyone in that community then decides we're changing the rules of the smart contract, then if everyone agrees, then that's what's going to actually happen to it. And then those changes are applied. I think that's really cool. Like that is democracy as a service, right? globally available, and yet still being composable, right? You can just go down as many layers as you want. And you can take those shares of that control and then put them into something that provides collateral and a liquidity pool and like gain yield on it. Just you can stack all these blocks together and just do really wild stuff.
So again, I hate to be the person who demands the actual answer to the question, but that's kind of what I do.
Sorry.
So again, none of that makes sense to me. So what you described in the second half just sounds like shareholders. We already have this system, which is to say that we already have the ability to buy Twitter, and the people who buy the most of Twitter are the people who get to control the decisions at the end of the day about, which programmers are allowed to change. You gave Twitter's example, that's why I'm using it. About whether or not it supports certain stream APIs or other things like that. So what I effectively heard from you was 2 what I would consider diametrically opposed benefits. So you can't have both of them, so I'm not sure why they were both touted as benefits, because you either get one or the other, and as far as I can tell, we can already have both. So the first thing you said was that you have a system where once I deploy this thing, it's reliable. Meaning I know what it is because, nobody can change it, right? It's like it's on the blockchain. To me, that sounds unworkable because if there's one thing we know about modern software, it always has bugs in it. People can barely go a week without patching bugs in their software, and unless there's some argument as to why code on the blockchain is going to be different, which I think would be almost impossible to make, because if anything, code that has to be on the blockchain is much harder to write than other code because you have all these security concerns and things that are very counterintuitive for programs to think through. So even if we said it was equivalent to only writing current code, I think it would be ridiculous to suggest that we won't have severe security bugs, because we have severe security bugs in all code that's currently deployed today. So either we end up with a system where that is on the blockchain and reliable but has critical bugs because no one can fix them, because the whole idea is that you put it out there and now people can trust that it won't change. Well, that doesn't seem workable. And on the other hand, you're saying, well, we can put a proxy in front of it and then that way we can change it. Well, if we can change it, then we lost the original benefit of saying it was reliable, and we're right back to the exact same problem that we had with Twitter, which is that whoever is in control of that, regardless of who it is, can now just make the decision to remove some critical API, such as the streaming API. And if the argument is, well, the people who will be in control of that will be democratically decided by the people who choose to buy NFTs, well, those are shareholders, which we already have. So as far as I can tell, what you're describing is just the current world we have, except with a very expensive system underneath that we didn't need because we already have the thing, which is the real world. But we didn't need to build blockchain for any reason at that point. Where did I go wrong?
Where I went wrong is in the way that I explained it.
Okay.
I think so. The reason that it seems that I was making contradictory statements is because I'm describing two different options.
Yes.
One thing that you can do is,
but just to be clear before you go further, there are two options that we also have in the real world. You could have done either of the. If it's an option, then it's the same as the real world, because the real world also has this option. There's nothing from stopping me from putting out a public contract with my service that says, we agree to never change this code. I could do that. Or I can do the other thing, which is say, I'm a public company, we have shareholders, and we're going to take direction from the shareholders. They decide what we do, right? So we have those two options in the real world, right? So again, factor that into your explanation unless I'm missing something about why blockchain would be basically the same.
I don't think that we actually do have those two options, those options in the real world. So there is no contract that you can construct in the real world that ensures that a service will remain running. If you were to construct such a contract that said, like, I'm going to provide this service in perpetuity and keep it the same, and everyone agreed, well, if the company goes bankrupt, then you can't enforce that in our legal system anymore. Like, the thing just disappears.
But that's true of a blockchain too, right? If people lose confidence in that blockchain and it goes away, they switch to some other blockchain, same is true, right? So the underlying deployment can certainly be destroyed in either case, right?
That is true. If the entire blockchain disappears, then the thing will stop running. But because it's a protocol that if any number of people want for it to continue to running, they can pick up where anyone left off, right? If Twitter goes down, it's gone forever, right? And there's no way to actually recover the state or the code or anything else. But as long as there exists some number of actors who want to continue to using this service, then everything that's built on top of the blockchain should continue to function in perpetuity.
So might we rephrase this as saying what you're really talking about then is the ability to make a distributed backup, essentially. In other words, the benefit is not so much that I'm getting a guarantee about that this service will be provided in a certain way. It's more a guarantee that if the entity should fail that's currently running the service, well, at least we'll still be able to run the service because we're all keeping a distributed backup of the state of the service. So we don't need them to continue doing whatever it is they're doing.
Sort of, but I mean, I know that in theory, right, a lot of these things about composability could exist in the real world. However, I fail to actually see them actually working or existing, right? So if you wanted to take, say, the governance about some sort of rules and then distribute that and then put it like through an automated market maker and then actually like trust that all of those things do in fact happen according to the rules, how would you actually do that at a global scale in the system today?
Well, I mean, I'd say two things. One is that there's nothing currently prohibiting people in contract law from doing this. And in fact, governments have literally imposed this. I would argue FDIC insurance is an example of the kind of thing you're talking about. That somebody stepping in and going, look, this system works however it works, and your bank may be terrible and may fail. And what we're going to say is there's a hard limit on how much money you can lose. You can only lose your excess of $200,000 or something, right? So that's an example of a guarantee that is placed in a real world system, and it actually appears to work quite well. The reason we don't do that most of the time, I would argue, is because nobody wants this. If consumers in general wanted mostly the same thing they had 40 years ago, then you would have businesses providing that. But usually what people want is new things that are ostensibly better. These days you might argue are just things people have been convinced are better but are actually worse. But either way, consumers are making that choice to go out and buy this new product rather than the old product because they thought it was better. They want the Tesla car, not the Ford car, not because they were forced to buy it because people weren't still making the old kind of gasoline automobile, but because they wanted the new thing that came along. It is usually why systems don't have this guarantee. I would argue the same is true usually of things like Twitter. If people were sufficiently upset about the fact that Twitter dropped that streaming API, they probably would have a much harder time doing it. But the reality is consumers don't really care about that very much. What they want is whatever Twitter is providing, which is a homepage that they go to that, they can post low quality 250 character opinions on or something, right? So I would say, I don't know. I can think of examples in the real world where we have those guarantees, like FDIC. I think the reason we don't tend to have companies that do that is because it's not what people actually put their money towards. But even that, you see, sometimes you do get things existing. So in places where people are paying for something that is permanent, you have something like art collecting. People buy they buy this Mona Lisa, the original one, because that's the thing that they wanted, and we have systems for doing that. I don't know. Like, it doesn't really seem to me like I'm seeing the difference. But again. This is the first interview where I've really talked about Ethereum, so keep that in mind.
Sure. I wish I saw the world in the same way as you, where I did not see a difference between these things.
Okay.
But what I actually observe, right, when looking at the behaviors of large tech companies, it's that the motivations of consumers and of businesses are fundamentally misaligned. So, for example, take your Facebook, your Google, your whoever, those businesses are incentivized to control as much of your data as possible, to create a silo around that data, and then to rent seek on that. And so as a consumer, we usually start off with seeing that a business has maybe a free model where for a time when they're trying to build up a network of people, they are offering services for free, and they're bootstrapping that network, and everyone's providing data into their system. But then they will switch a while later and reveal what their business model actually is, and then that business model will just tend to be pretty terrible for consumers. And then your options, you don't really have a lot of them, right? You're kind of, you can leave, right? But you've already actually contributed to the network effects of this business succeeding, right? By like curating some kind of a network or providing data or what have you. So then you lose out on leaving, and you also kind of lose out if you stay as well, because now you're paying for whatever it is that they are asking for, whether that be mining your data, whether that be rent seeking, whatever. You're just kind of stuck with it. So the assumption, right, that the world is the same in these two systems is not actually what I actually see playing out in the real world.
Oh, well, sure, but I mean, I think the more specific question though is that really true? Because again, like you said, I don't really see why the second case you gave, where you have a proxy and there's governance, would actually go any differently, because of the part that actually I think is not true of what you said. I agree that these corporations currently are incentivized to do what you're saying, but the reason they're incentivized to do it is because that's the consumer behavior, meaning consumers themselves are choosing that model. They want the free service rather than the pay service. Ergo, the market created this solution, which neither you nor I would probably have picked as our solution, but that came from what consumers are willing to spend money on. They would rather go buy a hard asset, or consumable, like, food, for example, and have this service provided to them for free than, put a certain amount of money towards it for whatever reason. saying that things will be better because you've prevented them from doing that is not necessarily something I'm ready to say is not true, but you would first have to actually demonstrate that it is true in order to claim it was a benefit, right? You could claim it as an experiment, but it's not necessarily a benefit until you've determined that the services that people end up with at the end of the day are actually better. Especially if one of the arguments for a system like this is that it is designed to reach people who previously weren't being reached. Well, Facebook right now reaches everybody, because no matter how poor you are, if you can manage to get internet access at all on some really cheap, super crappy phone in a war zone even, people are able to get access to this service because it is effectively subsidized, for lack of a better term, by wealthy people in other parts of the world. I mean, that's sort of what's going on. If you want to make the argument that the world would be a better place if we prevented that from happening so that only people with enough money to actually show up and use this service by paying for it will have access to it, well, you might be right, or you might take away that global subsidy that's currently existing, and you might end up with a much worse world where only people who are fairly well off have access to things like social media. So while it could be true, it's a very big if. And so unless you have a reason why you think you can concretely demonstrate that it's definitely true, I'm not sure that's a benefit. It's just a difference.
Yep, that's an interesting argument for sure, and it's the first time that I'm actually thinking about this argument. So I apologize if I don't have like a witty answer.
Fair enough. Fair enough.
Right off the fly, right?
And you don't have to. Other people will talk on the stream about these things, right? So, I put them out there only because you brought them up, so it's good to talk about. If you don't have an answer, the can will get kicked forward to somebody who's been thinking about that aspect of it. Let's say, right?
Yep. So for me personally, I would much rather pay to have access to data.
Me too.
And I would like to be able to rely on that data that's being provided, know that it hasn't been manipulated, be able to verify access to that data. That would be very valuable to me. Now, whether we have to use that model globally, especially for people who can't necessarily afford to pay for data. Well, first, the actual fees for data that we're seeing right now on our network are pretty low, right? We're talking about fractions of a penny typically to make a query. So this might be accessible even in a third world country, which sorry for using that term. It's not like a great term. Doesn't mean as much as it used to. Anyway, to someone of lower economic status would be difficult, or not as difficult as you might think.
Well, just to be clear, though, I don't really want to. I don't want to focus on that specific aspect. I was just pointing out that currently the system is a market where consumers make a choice, and the choice that they're making in certain circumstances is that they don't wish to pay for certain types of services, right? They want these services to be free, at least initially. And while the argument might be that, well, okay, the consumers just don't know what they're doing and they're making bad decisions, and what they should be doing is paying for these other services, at some point someone has to acknowledge that if the argument is we want to stop people from being able to have that business model, it doesn't necessarily follow to me that that is some kind of a benefit overall, because it sounds to me just like someone making a decision about what business models they decided were good, which also doesn't really sound like the point of crypto either. So again, it doesn't. It seems kind of like a rat hole that doesn't really work to me. To start talking about the fact that these things are better intrinsically, if it's about providing the option, again, I'm not convinced you are providing the option, because I feel like a company could just come out and guarantee those things, and you're definitely not. I would say, even from my perspective, the blockchain isn't forcing people to do this anyway. Because like you said, you have the option on the blockchain of providing the service for free with ads, probably. I mean, you could construct some system where I haven't thought about this for more than 10 seconds, so I'm not sure how you could do it. But let's suppose we have a system where the ads cryptographically sign that you watched them. So when you go to redeem your ability to use this service, you have watched an ad that cryptographically got warranted back to the blockchain. So now you receive the necessary amount of whatever to run the program that gives you the video content you asked for or whatever. That's a bit far-fetched, but you could imagine that being constructed in the future. I just don't see what you're talking about as really implicating the blockchain at all. I feel like not only could we do all these things in the real world, but the blockchain can also do the bad things that you're talking about.
Sure. So I think this is actually the point where I think I've narrowed down now the point where we probably disagree.
Okay.
Which is that I don't think that consumers even have this option in the real world, and there exists no such technology that would enable it.
Okay.
So if I wanted to visit a website like the New York Times or whatever and pay 5 cents to view an article, I would absolutely pay 5 cents to read an article, or visit some random website and pay a fraction of a penny for something that I wasn't sure if it was going to be good yet or not before I actually used it.
Well, I definitely wouldn't pay 5 cents to read something in the New York Times, but I definitely would pay 5 cents to read it somewhere else.
Okay,
sorry.
Yeah, so this is the first thing that,
I'm just joking.
that I thought of.
I'm just joking.
But the options that I have today are free with ads or subscription. And I do not have a subscription to the New York Times because the number of times that I actually want to read any particular article from one website is like once a month. And I want to actually view a lot of content on the internet, and they all don't come from the same sources. But there exists no technology where I can actually pay for access to that content in a way that I know that I'm actually getting the content like that I was asking for, and that I can send a small enough payment without enough overhead that it would make sense. Because like if you're going to use a credit card, well, then the minimum is going to be like dollars.
So that is true already of a number of things, such as like video games, right? And what they've done is they've established their own like V-Bucks thing, right? So I do agree that in general, the solution to the current payments problem seems very clearly to be that banks, for reasons that, may be regulatory or may just be because banks are lousy at technology, have not been able to enable microtransactions, and we've seen that across the board. So I totally agree with that, but that's kind of moving forward, right? That's not really talking about the permanence code on blockchain VM stuff at all, is it? I mean, because microtransactions have nothing to do with the VM side.
Do they though? So
okay, yeah. Like if they do, please elaborate. Games, yeah, please elaborate. Yeah.
Considering video games, right? Typically, the way that those works is that you have to make some large purchase, like $10, $50, what have you, sort of onboard into their system, and then actually make payments within their centralized system. And that's is a custodial relationship where they would actually be able to shut down and keep all the money or whatever. Pretending that we don't care about that, there's an enormous amount of inefficiency in having to pay that collateral upfront, right? So like if this system exists where I can pay money for content online that is verifiable in like very small amounts, if it exists, I don't actually see it.
I guess I'm just trying to figure out, does this have to do with the VMs or the microtransactions, though? Because it seems to me that microtransactions are enabled without needing things like VMs, right? You can just have the microtransactions. I mean, unless what you're talking about is the fact that you think that Fortnite will somehow run in an Ethereum VM. Because without that, you don't need any of the VM stuff, because you're already saying that there's an external service that has to be running in order for these things to be worth anything, because without Fortnite, having a Fortnite skin doesn't have any actual value, right? So, in theory, you would have to say, well, all we really cared about was the microtransaction, not the VM. We just need the microtransaction, the record of the microtransaction, because once we have that, then Fortnite can properly deploy the skins. And, I don't think we need that much assurance that they're actually going to do it. I mean, I think if they started not honoring those, we'd be fine. So isn't that just a microtransactions thing and not really have anything to do with the VM, or am I missing where the VM is important here?
So keeping with the skins analogy, which is sort of not a great thing because it runs into the two generals problem again. But you could have a record of all of the microtransactions by delegating to the blockchain, so that if there was ever a dispute about what the microtransactions were, you'd be able to like pull up all the records and prove that you in fact owned a skin, right? I'm not as interested in skins as maybe a lot of people are. I'm much more interested in this use case of being able to access data for small amounts. Mm-hmm. And so like if you're working within the context of Fortnite, then maybe there's not even a lot of benefit to going decentralized, because there are already developers going to be updating this thing and so on and so forth. And you are, but I mean, you could, if you wanted to not trust that Fortnite was going to be run forever, you could run it in a decentralized way, which would allow you to play the game even if the company went under and still know like who had skins, right? So when you pay for a skin in Fortnite, you don't really know that is yours, right? Because at any point in time, that company can disappear. They can, just decide not to give you the skin. But if the game is built in a decentralized fashion, then as long as there are players of the game, then they can convince each other verifiably that they have a skin and they can continue to play that game in perpetuity without running all of Fortnite on the EVM, which would be silly. All you would have to do is just be able to query the transfer of assets over time, which is something that you can do exceedingly well by indexing blockchain data, which is actually exactly what we do at the Graph.
Right, but there's no... in other words, that is something that is... The company who makes the game has to also make the game run decentralized, which nobody does. And blockchain doesn't really enable, does it? I mean... In other words, I agree that if for some reason what you thought was valuable is having a public record of who owned what skins so that you could, I guess, double check Epic's accounting, or I suppose the more interesting use case might be that if you believe that what would start happening is that people would pick up Epic's skin sales if they went out of business or separately, right? Like we can see you bought this Fortnite skin and we want your business, so we're willing to honor that Fortnite skin in our game or something like that. I can see some value certainly in that, which is to say that having the record be public allows some other use cases, but it doesn't seem like preserving the game is one of them, because if the corporation was going to do that, they could have already done that. And it's actually quite difficult in today's landscape because one of the things that you typically do is not release the server code for cheat reasons and so on. And, they're run on centralized servers that can't, we used to run games decentralized. People would just run a server, but they don't do that anymore for a number of reasons, right?
Right. Well, people actually do, though, today run decentralized games. And they do track asset. Like this thing that you're saying doesn't exist, does. And what cryptography buys you in the mix is basically just distributed anti-cheat.
Why does it? How does it handle a distributed anti-cheat? Oh, you mean distributed anti-cheat of running the server?
Right. So you no longer need a centralized provider to run a server. So like, for example, if we wanted to play a game of poker against each other in a decentralized way, we actually can do this using cryptography by performing a shared computation together, where we would shuffle the cards in a shared way such that you would be able to view cards that you were able to get access to through playing this game. And we'd use, say, commit and reveal strategies basically to say what our actions are and then be able to sort of reveal those to each other simultaneously in a way where you can actually run an entire game right from front to finish without relying on a centralized actor. So those things are possible. I don't know if we want skins in our decentralized poker game
Well, you might as well.
Custom playing cards.
So you are then
You
talking
might as
about
well.
putting the game in the blockchain, meaning the game would
No,
run in the blockchain to the extent that we both agree what the code is for the game, I guess. Or maybe you don't mean that. Maybe you just mean, look, we're going to run the game separately, and we're just going to use cryptography to model the world state so that if you were cheating, it wouldn't actually do anything other than you would see yourself win the game, but I wouldn't. Meaning, I would see you lose the game because the only state you could change was the state that you were seeing on your machine, basically.
so we might be starting to get into scaling a little bit.
Okay.
But what we can do, so in this way where we have a decentralized poker game where it's based on cryptography and commit and reveal, there actually is no way to cheat. The only thing that you could do is stop playing the game. But what you might do is set up on chain something like the rating system for that game, where we have ELO or whatever. And ELO is essentially a kind of transferable value. And so we can create an agreement where we would play this game. And if that game ever failed to progress, kick it back to the chain. And so we'd be able to play all of the game offline and then be able to convince the chain after that the game has been played and that there's a particular result and what the transfer of value was after that.
Right. This is what I meant by saying the only thing that you could modify is what you saw on your machine. We actually had this a long time ago when we used to do real-time strategy games where you would play versus each other. They used to do things by just sending the moves. So that way, if you decided to cheat, all that would happen is your machine would appear to, you would have had the cheat, but you can't actually influence the cheat on the other person's machine because it's proceeding with the agreed upon algorithm and you're not. So, et cetera, et cetera. But okay. So I guess I'm not sure where that falls, though. It's probably not worth going into detail on because, like I said, the games that people play currently, you wouldn't be doing that. I mean, it would be very unlikely that you're going to rewrite Fortnite using this scheme, although maybe you are suggesting that we are. There's the games that people actually play today that are the big games where people use microtransactions. They don't... I would not imagine they would admit a way to write them in a cryptographically secure way such that they could be run distributed in this fashion, although maybe you think they could.
I think that people are working on this.
Okay.
I don't want to say too much because this is not my area
Totally
of
fair.
expertise.
Totally fair. But you think they might?
I think it's possible for a large category of games. I think for a lot of the sort of twitchy games like Fortnite would be more difficult because I know what goes into things like hiding latency in those games and making sure that all the problems with lag, right? And so if you're going to go with a commit and reveal scheme using cryptography, you may introduce an extra round of communication, and that might actually just be too much. So I don't want to say offhand that it applies to all games or all games played across sufficient distances between people. But yeah, again, not my area of expertise. But I think like you can actually go a long way with this, a surprisingly long way with this if you wanted verifiable outcomes for games.
Well, that's interesting anyway, then. I might try to get some, if you happen to be able to point me maybe after the interview towards some people who are working on that. I would be interested in talking to people about that because I'd like to know what they think optimistically about distributed, because in some sense that's separate from blockchain as well. That's just an interesting technology. Like how far, ignore blockchain. We just want to make a game that can run distributed, but where we don't have a lot of concerns about the fact that there's a server who's cheating. How far did you get? Right, because maybe they're further than I would think, and that would be interesting to learn. Anyway, let's return back to a topic of your choosing, since I've gone down a couple rat holes now where you've brought something up and I just kind of wanted to drill down. What would you like to hop back to?
Scaling, I guess. That's what I actually work on. So
okay.
I'm increasingly nervous about these other questions.
Okay, totally fair. Take it away, scaling.
Scaling. All right. So last thing when we talked about was just like non-pessimistic optimization, right? And why so the base chain is implemented in this terrible way, and it could be a lot better. The next thing to talk about is something called rollups, and rollups are the answer to the question if we are looking at the problem from a parallelism and data compression perspective. So the basic idea of rollups is to move the compute and the storage off the blockchain as much as possible and just use the blockchain for the data availability and like sort of the consensus around that call data. Like basically the blockchain becomes a journal, right? And is not necessarily used for managing all of the state and the compute. And when you do that, you can inherit the security of the base chain so that if there's only one honest participant, that's all that's really required to be able to resolve being able to prove things about that state. So typically there will be some kind of process to either if taking that journal, either performing the compute in a verifiable way where you can produce a zero knowledge proof on chain that says, hey, now there's this new state root and I can now prove things about that data and I can prove that the computation was correct so that you can rely on this, or you can go optimistically, something called optimistic rollups, which basically just accept the state. But the trade-off there is that there's kind of a thawing period before where we allow people to contest whether or not the state is correct. And so you add something like a refereed game, which is what we started talking about earlier, where you can bisect computations and say, hey, the state before was X. I'm claiming that the state is now Y. And if you disagree, then you can produce this challenge and say, well, I think I think that the end state's wrong. So I'm going to say halfway through the computation, the state is this other value. And so then the other person has a chance to respond and say, well, either your first half of your computation is wrong or the second half is wrong. And they can drill down until it's like a single instruction. And then the chain will execute that one instruction using its normal sort of compute mechanisms, and then you'll end up with a result, right? And then there's all kinds of economic systems based on making sure that people aren't spamming the thing. So if you do something wrong, there are heavy penalties in the system, and those are kind of your nuclear options, right? Where we're not expecting this challenge protocol to be used very often, but it has to exist. So typically, it's just that data is going to be available for offboarding off of that chain within a week or something.
So can I ask a question about that? That I suppose if you don't want to get into this, we can just push it off. But it is a question that I've had about some of these schemes, because if you look at a lot of schemes for resolution or for ensuring good behavior, there are actually a number of them that involve the concept of penalties. Notably, the original blockchain stuff, like the original Bitcoin paper, for example, you don't see a lot in the way of falling back to penalties. It's more about investment. It's more about, look, you need to have bought this much compute power in order to mount an attack. But when you start going the optimization route, I do see a lot of people talking about penalties as an enforcement mechanism. They're like, blah, 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 here's this thing we're going to do. And to make sure people don't just constantly do it for denial of service or for some gain or whatever, there's a penalty for being wrong or for asking the server to do it. I assume that in general, all of these schemes have to first pre-check that the two participants could pay the penalty if they lose. Is that correct?
Yeah. So when you with Arbitrum, which is a example of an optimistic rollup, what you do is when you post the new state root, you also post a bounty, so that if anyone challenged you and won, then they would be able to claim that bounty.
And so does this create problems? Like the main thing I thought of when I was looking at these was, does this create a problem where people who are insufficiently capitalized cannot execute challenges because they can't put up the stake necessary to challenge?
You don't have to put up a bounty to challenge, I don't think. I need to double check this, but you're not making a claim about the truth of the base system that's like in any way interesting for security. So all that you would have to be able to pay is the miner fee for executing the transactions that would implement the refereed game itself. And those should be much less than an actual bounty for like submitting a state root that would be challengeable. And so because though you will know the result ahead of time, and because you know that you can claim this bounty, you should be able to just get a loan, right? Or if you start the challenge protocol and you know how much it's going to cost ahead of time, and you know how much money you're going to make by winning, and you know that you're going to win, getting that capital shouldn't be terribly difficult.
Okay, I guess I'm not sure I understand then. So if I am the person who is making a challenge, and I don't have to be the one who stakes the money in case I lose, that means there are two parties or more, I guess, out there. There's at least two parties who do have to be able to stake, because those people are the people who are going to have to pay in the case of a loss, correct?
There's only one person that's staking. That's the person who has submitted what they believe that the new state root is going to be after running the computation. And so the referee here is the blockchain. Like the Ethereum is the referee. So there's, if you want to say maybe that miners are able to stake in some way because they're just executing the blockchain and there's already incentives there, then I guess you could call that the third person. But there's not really I don't think of it. I like to say that it inherits the security properties of the base chain. That if you assume that the blockchain is already working, and that's something you would just debate separately, then you don't need another participant to referee the game, because it's the smart contract and the code in that smart contract that referees the game.
Okay, so the challenger pays a very low fee, which is the fee for the blockchain running the thing. And the the person being challenged is the idea that they always put up this money as part of them submitting the new block. And then eventually that money is no longer escrowed after a certain amount of time has gone by, at which point you're no longer allowed to challenge. Is that the general idea behind most of the designs?
Yeah, that's correct. I think for Arbitrum, the amount of time is a week. And I think also, but don't quote me on this, that you may be able to just roll over your bounty. Because if you've submitted one bounty, like $100, and then you submit a new state root, there's no reason to keep both those bounties separately, because if someone's going to challenge, they're either challenging the first state root or the second state root, and things would be invalidated from that point. So I don't know that you would really need more than one, because they would just always challenge the first state root. Maybe not. Maybe you actually need both.
Well, but either way, I guess, I suppose. Thanks for clarifying that, because I did want to understand exactly how that system worked before we went forward. Because, that makes sense to me, because you're basically saying, look, the bounty gets put up by the person who's putting on the state root, so they know going into it that if that's not something they could afford, they probably shouldn't be, miner's probably the wrong term. They shouldn't be a person actually on that level of the network if they can't stake that bounty, because they knew going into it that that is what you do at that route. So there isn't a implication, because the person challenging, who might be the little guy, they don't have to pay the heavy cost. So that seems logical, right? Unless I'm misunderstanding.
Yeah, that seems logical. But also take into consideration that we would expect this challenge protocol to be invoked very rarely.
Yes.
Because the computation is deterministic. So you know ahead of time whether or not you're going to win the challenge. You know ahead of time, if you're posting a state root, that someone will just take your bounty. So like, why would you do that?
Well,
Yeah.
the
Again,
reason you
there's
would do
two
it is if
families.
it wasn't designed well and other people couldn't afford the bounty often enough. That's why I wanted to get that right. I wanted to drill down and go like, okay, yeah, this seems like the money is in the right place, right? Okay, so anyway, continue back from talking about the refereed bounty.
Right. So I just want to say again that there are two families of ideas. Right. One is that the optimistic rollup, which is what we just talked about. You post a state root, and then there's some kind of refereed game or something. We call it fraud proofs, where you can show that the result is probably not correct. The other kind is a zero knowledge proof, where you would actually post a new state root and then execute a computation on chain was synced, but validated that you did the computation correctly. And so with optimistic rollups, we talked about before, they're basically live today. Like you can use them. They're not that hard to understand. Zero knowledge proofs are a lot more interesting because they're instantaneous, and it doesn't have like these questions around a challenge protocol or what have you, but they're somewhere between research and implementation, especially like if you want a general purpose zero knowledge proof. Like we can make very efficient zero knowledge proofs for specific cases, but if you want to do that, you need to find a cryptography expert, of which there are not very many.
It's very difficult. Yes.
It's very difficult. Right? If we want to get to the point where we have like zero knowledge boot camp and anyone can just deploy, that's going to be a little while.
Yes, yes, that may be tough to accomplish, but yes.
Right. If we do have that, though, it's another option for doing rollups, which is kind of compelling because of the way that you can offboard data basically instantaneously. So those are kind of fun. Rollups will typically do more compression too than the base chain would. So like I think these are things that we could roll into the base chain like Ethereum, but where they live right now is in rollup, just because of like a hack, I guess, to get around the fact that the base chain doesn't provide any of this. So compressing data, right? Because with the rollup, you're paying for the call data itself and not the computation as much and not the storage as much. So we might use for signatures, we might use something like BLS, which is a signature scheme which allows you to take a set of valid messages and a set of valid signatures and aggregate all of those signatures and just make the aggregation value public. And you post that on chain with the messages, such that in your optimistic rollup or in your zero knowledge proof or whatever, you can then validate each of those signatures or each of the messages were signed by some particular address using that small amount of state, right? So compression techniques like this live in rollup land right now. There's other things you can do to save on data. Like for example, you might use table lookups for addresses instead of a full hash, which is going to be very large by comparison. Maybe use variable length encoding for data, this kind of stuff. To decompress it, it all takes compute, and compute is a lot cheaper. So that's kind of your approach with the rollup, is to do as much compression as possible and just use the base chain for state. And taking all these things together, looking at a lot of typical use cases today, about 100x is an overall estimate for how far you could take this on Ethereum 1, assuming that research lands for zero knowledge proofs, and more applications switch over to rollups. Right now, we're not seeing quite as many gains right now, in part because a lot of the base costs are kind of expensive. Like if you're going to post a new state root, that has a cost regardless of how much you have going on under the hood. You're paying that cost, and so you can amortize those kinds of costs, right? But people think and have shown math to see that it's going to be between 70x and 500x depending on the characteristics of the work that you're trying to do. That's rollups. Do you have any questions about those?
So, I guess I would have two questions about them. One is a fairly simple question, and one might be slightly more complicated. I'll start with the simple one. The simple question is just to be clear, what is the problem that we want to solve when we talk about something like a rollup? Meaning, are we trying to avoid the cost of distributing all of the information that was going to be required to track what we're doing to all of the nodes in the network because the transmit cost is too high? Or are we trying to solve the problem of not everyone storing everything? So we're literally just trying to reduce the total space. Is because both of the things could be potentially concerns. Is it both? Is it one or the other? Is it neither?
It's kind of both, right? I think of it as just a parallelism technology, right? So at a fundamental level, what you're doing is you're segregating state and compute into different places. So not like compute for a rollup does not have to be performed by someone who is validating the base chain. They can perform other, other work, and that means that you can now spin up other nodes that just have these single responsibilities. You don't need a global network to validate that the state of the rollup is progressing correctly. You only really need one honest actor to make sure that this continues. So that allows you to break up your problem into many different pieces, run those in parallel, and plus kind of gain the compression techniques as a hack for today due to the fact that they're not really supported by the base chain.
And so my second question is, what is the in practice? So intuitively, one would assume that if what happens is that the base chain itself is the authoritative record of what actually happened, and we're assuming that we must need that because if we didn't need that, why do we even have a base chain? So we're going to assume that we need a base chain because otherwise we wouldn't have made one, and that it's the only way to really know what happened is you have to have committed something to the base chain because otherwise why do we have one? What is lost by going to something like a rollup? And we can ignore even the term rollup. Just what is lost by going, we're going to do a bunch of stuff off of the main chain, and then we're going to commit it back to the main chain. And obviously all of these things usually involve, like you said, some kind of a refereed game that follows because people need the ability to challenge what happened, because if they disagree with what you did, they have to be able to say, hey, wait, that signature doesn't match the thing, or somebody has to validate it at some point. What is lost by going to that off-chain system, and is it important?
Yeah, I would say that what is lost is that it's now less efficient for either two rollups to communicate with each other or for data within a rollup to communicate with the base chain. So one of the things I was advocating for earlier was that you have these composable systems, right? But with if you have a rollup, then data is kind of siloed. You can get data off, and in some cases you can get data off fairly efficiently, but it just takes longer and it's less efficient to kind of onboard and offboard data onto a rollup, onto the base chain, onto some other rollup, say, right? It's kind of the same thing that you lose when you do parallel programming in general, is that you now pay synchronization costs.
That makes excellent sense. Is that, to what extent is that a practical barrier? Because I'm also assuming, and I guess I don't know, maybe you can answer this question as well. I'm assuming that if I'm doing computations, well, computations are wrong term. If I'm doing, let's just use the word transactions. If I'm doing any kind of transaction, whether that involves computation or not, inside some kind of a parallel chain like this, I presumably have no actual guarantee of when that will become externally visible. Now maybe that's wrong, but I'm assuming that that's true. Does this create difficult barriers for what you're talking about. Meaning, I want to be able to sell this one asset and buy this other asset, which should be a very straightforward transaction, but in reality, I'm running into these real-world practical problems because the asset I want to sell is in this parallel domain and the asset I want to buy is in this parallel domain, and they have very unpredictable sync up times, so it's creating this really big barrier to the economy where that round trip is not happening or is too expensive to happen. Can you perhaps elaborate on that? So it seems like something that you've thought about more in terms of how these things will scale.
Yeah, so there are some technologies which can aid with this a bit. So for one of them is something called the NXTP protocol, and that's built by Connext. And what that does is allow you to create a state channel game where you deploy smart contracts on both that will let you actually do exchanges across a rollup without necessarily even going through the base chain. But you need liquidity providers to make this kind of thing work. And so then there's questions about like what is the capital efficiency of such a system going to be like? Because you can just generally trade off latency for capital if you're willing to work through an intermediary. But sorry, I think I might have forgotten half of the question. But it was like, how bad is this problem? In the zero knowledge proof case, you might be able to get data offboarded within a block, but that's still not the same as being able to use data inside the same block. The level of interaction that you can get between of composability for very interesting smart contract usages is going to be lower. But if everything just goes onto rollups, or even like one rollup, like if you just imagined Ethereum today, it just gets taken over by one rollup, then it's not a problem. And if there's fragmentation, then there's more of a problem. But there's kind of technologies that help make the problem not as bad.
Well, but if everything went on to one rollup, then you wouldn't need the blockchain because you just use the rollup, right? I'm not sure I follow.
So it would be like a blockchain that is not implemented the way it is today, right? The blockchain would be primarily for data availability. Although I guess you would run into like a scaling limit, I guess, what you're probably pointing at, where if you have more storage and compute and everyone has to validate that, then you're not actually gaining any parallelism, and that's a fair point.
Because I'm assuming that the only actual benefit to a roll, like if there was some benefit to just being on a rollup, then that's just how you would design the blockchain, your root blockchain. So presumably the only benefit of a rollup is that we can run two of them at the same time, and they only get reconciled periodically, which allows us to get the parallelism. Like you're pointing out, the analogy to CPU, to me, makes a ton of sense. It's like, look, we've got multiple cores. We know that it's going to cost something for them to communicate. So in general, you're going to have to structure your algorithms, and in this case, the word algorithms is financial system, to effectively be aware of the fact that transactions that are local are faster and potentially more powerful than ones that are remote, because you just won't have the same knowledge that you have to do a remote transaction because you will have to wait. So you've got a lead time when you do that move, right? I mean, I assume I'm explaining that fairly.
Yeah, there's a little nuance I'd add to that too, though,
Please.
Which is that there's kind of two clocks that we need to be running. One is basically like how fast can we move the chain forward, which you want to be as fast as possible, right? But then in the case where someone wants to start fresh and start validating the chain and kind of catch up and be able to contribute to this or make sure that the state is correct, you want that to be verifiable as well. So if you have a zero knowledge proof based rollup and you can let the chain run forward as fast as you can with like compute, but then maybe introduce some latency or something where you're then providing a zero knowledge proof from that and then post that to the chain, and like that's your rollup structure. Then someone can actually go start from Genesis and just catch up really fast because they don't need access to all the underlying state and whatever. They can validate that themselves very quickly, so that there's nuance, right?
Okay.
Cool. Ready for the next part?
I believe so.
Okay. So then if we've answered the question of like, how do you increase the amount of compute and storage based on some amount of available data? Like the next question that you want to ask is, how do we get like a lot more data that we can actually use? And that's the question that quadratic sharding answers. And quadratic sharding is, hey, why don't we run consensus over these different streams of bytes separately and then synchronize those data? And the big question around that kind of makes it a trickier question than you might think, is how to ensure that all of that data is actually available. Right? So if you're someone who wants to validate the blockchain, and there's now, instead of just one blockchain, and there's like 64 of them, well, you have to download all of the data, which might be a large amount of data. And you need to make sure that that data is in fact available. Because if someone starts to make claims about data, they don't actually have the data, maybe it doesn't exist, it's not available, then it's difficult to actually prove them wrong. It's actually impossible to prove them wrong. It's something that you just can't do. So we need to expand the amount of data while ensuring that that data is available and verifiable. And then, so the way that quadratic sharding implements this, at least for Ethereum 2.0, is something called Kate polynomial commitments. And the way that that works is that they take each of these blocks that would be, independent, encode those as a polynomial of degree n, and then expand the size of the data to twice what it actually would have been if it was just the raw data. Sample that polynomial to get some more points. Basically, you just have twice as many points as you need. Hash the polynomial so that's what your Kate polynomial commitment is a hash that lets you prove things about the polynomial. And then what a consumer would want to do if they wanted to verify that that data existed with high probability is they would randomly sample points on that polynomial. They would say, like, give me, point number 1, point 100. And if at least 50% of the points exist, that would let you reconstruct the entire polynomial. So if you say, like, grab 30 points, which are randomly sampled, and if 50% of them do not exist, it becomes highly unlikely that the polynomial either does or does not exist based on the responses you get back, right? So if I am flipping a coin 50 times, it is really unlikely that it'll come up heads all 50 of those times. So if I sample this polynomial 50 times, if up to 50% are missing, well, I have a 50% chance of either seeing the data come back or not. And so if I then see that I get the data back consistently, then I believe that the data exists with high probability. And I can use then the Kate polynomial commitment to show that the points that I sampled belong to that polynomial, thereby like kind of closing the loop, and then use that commitment to verify data against that polynomial. So what that lets you do is have the independent streams of data, verify that they are in fact available, verify that you can like prove specific questions about that data, and just kind of like unlock vast amounts of data that are not available before. And so the limit of that system is believed to be around 64x right now. Just once you start going beyond that, you start running into other problems. So basically, like when you're synchronizing, you want for the size of your synchronized block to be about the size of the limit of an actual block that you would normally want. And so then as soon as you can't fit more data into that one synchronization block, then you run out of space. So that's why it's called quadratic sharding. It's just because you get to square the amount of data that you want. That might have been kind of rambly and all over the place. Did that make any sense?
So some of it did. I mean, it may just make more sense for me to go read about it on my own, since I'm sure there's plenty of papers I can go to. But I guess the part that I wasn't entirely clear on is exactly what we were trying to ensure. So it was more I thought the explanation made sense. What I wasn't quite sure about is what problem we're actually trying to solve. So you were saying you need more data, and again, this I think a lot of this comes down to I just haven't talked to many people about Ethereum. So when you're talking about something like Bitcoin, you're not really talking about a large data store usually. Although, maybe you would be if you started talking about, subchains of Bitcoin or something. But um, so what I want to understand is you're talking about storing data, meaning we want to store data that the Ethereum like VM can access or that people can access and know is valid for whatever it is they're doing. We want to store a video on there. We want to store the code to a game. We want to store whatever. We just have a lot of stuff we want to store on there. We're talking about that, correct? Let me start with that basic question.
A subset of that question. So there's two kinds of data. There's the call data, which is essentially just your journal.
Yes.
Right? It's the data on the block stream. Right? Data in like a rollup, for example, can be hidden. That's kind of your intermediate state, like the results of computation and storage. We're not talking about that. We're talking about, since we've kind of like solved that problem a bit with rollups by being able to store data at different places and parallelize compute and distribute that data. We're not talking about that anymore. Now we're talking about feeding that by making our journal have a much higher throughput.
So this is actually data that's about what happened. You're not talking about ancillary data that we just want. We're talking about actual, like, the root data is actually what we're talking about storing here. We want to be able to have just a tremendous amount of data about transactions going through this thing and not have to worry that we're going to run into any kind of space limitations. That's what we're actually talking about.
Right. If this were Bitcoin, we would say we want many more transactions, but we're not concerned with account balances. But that is now a separate concern.
Gotcha. Okay. So what I wasn't entirely clear on is, so what you're trying to do here is you're trying to guarantee that people who say they are storing the data are storing the data. I mean, presumably you have a certain number of actors, and the actors based on, I'm just guessing because I haven't read about the system at all. I'm assuming each actor's, signature tells them which part of the shard they are responsible for storing or something like this, right?
Yeah, if you are participating in the Ethereum 2 mining system, then you'll be responsible for maintaining a particular shard.
Right.
But then that question, though, is if someone wants to validate that all of the data is in fact available, if the problem to validate that the data is available is downloading all the data, that's just too much data. So we need a way to validate that the data is in fact available while downloading a trivial amount of data instead of all of these like 64 parallel, ginormous, quickly progressing streams independently, which is harder.
Okay,
we need to validate that the data exists and that it is what they say that it is.
Okay, I totally get that then. And your explanation made perfect sense. That was the only part that was missing. I was like, I'm just not sure exactly what we're doing with it, but I get everything else. I do have one question then, which is hopefully very simple to answer, which is, why do we need to do this? Because I'm just imagining in my head, if all of these actors, you mentioned a number like 64x, meaning I assume that means that each node of the blockchain is responsible for 1/64th of the shard storage, and then it's replicated by the number of nodes. So if I had 256 nodes, then the fact that the shard quanta is 64 would mean that each of those nodes would store like each of the shards would be stored on 4 different nodes. Am I roughly understanding what we're talking
about? Each shard is stored on its own. Like there would be a set of miners responsible for each shard. I might not have understood the question. Can you repeat it? Or
not even a question. I'm just trying to get to the question by saying, so if there were 256 nodes in the network right now, which is a very low number, but I'm just picking an easy one. So if there were 256 nodes in the network and we're saying that sharding happens at a quanta of 64, then I would expect roughly, to approximation, because obviously it's random. It's a randomized process of assignment. Roughly each of the 64 shards is replicated across 4 on average mining nodes. That's all. I just wanted to make sure I understood.
Yeah, that's correct. Yep, okay. That's correct.
So my question is, what is this validation process for? That's the only part I was missing, because either they have the data or they don't. If they don't have the data, why does detecting that they don't have the data help me? Because the data's gone. So I guess I don't understand how that helps me.
If they don't have the data, then that fork of the blockchain is illegitimate.
Okay, so
right, because you could never actually do anything with it.
Okay, so what this is, I get it now. Okay, so am I correct in saying that what this is for accepting new blocks? When we accept the new block, we're going to query some subset of the data that is claimed to be warranted, that is claimed to be held, that this block requires, and we're going to use that as our decision as to whether to accept the block, or one of the things that we use to decide whether to accept the block.
Right. And in this process, it turns out that, if you wanted to actually reconstruct the data, you would just do something very similar to sampling the data, and you'd be able to recover the data effectively. Right. Like some consumers working together said, I want to sample this part and this part, and then you could in fact then recover the entire block if you needed to.
Okay, that all makes perfect sense. I'm on board. I like that trick. I don't know who came up with that, but I like that idea of like, okay, we'll make a. I don't think I'm quite sure I understand exactly one part of it, but I'll just go read the paper, which I'm assuming exists on this.
Yeah, I would like to send you more resources on all of these things. Like I said, our conversation is going to go really broad.
Okay. Yes.
And I'm not an expert in any of these things. I'm just kind of like saying, you might want to look at this and that and the other thing. Gotcha. And then according to what people said, we're going to end up here.
Yes.
If all of this stuff actually works.
Right. Yes, certainly.
Yeah. And a lot of this stuff's actually very well written. If you want to just start reading in general, I'd suggest reading Vitalik Buterin's blog. He's the who started Ethereum.
Yes.
And he's an excellent writer, and he just explains these things to people with any amount of technical knowledge. Like you could learn something if you already knew what Kate polynomial commitments were and how they worked. You still learn something from reading from him. If you didn't really understand cryptography, that's fine too. I don't fully understand cryptography.
Gotcha.
I still get a lot from reading his blog. Anyway, that's a plug.
Okay.
All right. So then from there, right, we've solved being able to store more state, do more compute, provide more data to the system. And then the next question we're going to ask is, well, do we really need like all the data to be public? Or if you can take some of that data and let it be private, or maybe even forget some data from time to time, because keeping everything around forever is inefficient, right?
And I assume there are two things we're thinking about here. Like one of them is that we don't want the storage cost to be unbounded in principle, which it would be if we never threw anything away. The other one, I guess, is it privacy? When you say wanting to make data private, is I assume the primary concern there is that we don't want certain people to be able to pry without a court order or without whatever. We don't want them to pry these transactions, which they would be able to do. Is that, am I understanding that correctly, or?
Some people would actually like to be able to maintain privacy, yes, and I think that's a feature for them. But I think from a scaling perspective, not making all the data available has its own advantages, right? If you don't have to have all the data go into that journal, then suddenly you have access to more data and more compute, right? If not everything actually has to be verified all the time. If you can do private communication between parties and then settle the outcome of all of that, like we were kind of talking about before with verifiable games and ELO, maybe like you run your game in private in such a way that if the participant doesn't agree, then you can force the result on chain, but you don't have to. You can just kind of settle the difference in ELO at the end without actually communicating all of the moves in the game to the blockchain if you don't want to. right? So these are called state channels, and typically they're used for micropayments or games. But I think they have more uses in scaling in particular. And the way that they work, the basic idea is you will deposit funds or some asset into a smart contract, and then set up the private communication channels between two parties and send messages across, which will later allow for a party to collect payment or enforce some results that they care about on the chain. And if you get fancy with this idea, you can enable something called routing, which is A has a state channel with B, and B has a state channel with C, and A wants to pay C. Well, you can say, I'll pay you if you pay them, and then allow that transaction to kind of go through participants privately, such that it doesn't have to be settled on the chain, but aggregations from these payments are settled on the chain. When I'm describing this, you're probably thinking of the Lightning network,
Right, yes.
From the previous conversations that you've had, that you've read about this. I read about the Lightning network like last night and this morning, and it was kind of terrible. So I apologize for any similarities, because now we're going to have to like dig out of the whole of what might be misconceptions about how this probably works.
Okay.
I think it was designed. It was designed a long time ago. It was maybe the first of its kind. I'm not like a history buff.
Right. Yes.
And within the constraints of Bitcoin and not of like general purpose compute. So it's kind of not surprising.
Well, the first,
some of the drawbacks that it has.
The actual first one, well, first one's tough, but Lightning Network was actually based on sort of the earlier one that I believe Satoshi Nakamoto, quote unquote, proposed. I forget what the names of them were, but there was a simpler side channel thing that he proposed, but that, they basically extended for Lightning Network. So Lightning Network was just like, let's make the more systemic version of this, doesn't have the same drawbacks. So they've been working on that for a while, I guess. I'm still unclear. We don't need to talk about it in this at all, but I'm still unclear on what the actual state of Lightning Network is these days. But, someone else will talk to me about that. So anyway, yeah, let's put Lightning Network aside. It was a very curious design that I wasn't super enthusiastic about. So it sounds like you're on the same page with that. So you probably don't have to spend any time convincing me that Lightning Network may have some jank in there. So if you want to just explain the part about this system that you think is important, we can just go straight there.
Right. Well, what it allows you to do is interact with the chain less frequently. So if you want to get to your, I'm going to pay the local coffee shop question, then maybe that coffee shop only needs to interact with the chain once or twice a day, or to collect all the fees from all of their customers with using their relationship with a single router. They'd be able to then deposit that money back into their merchant account or whatever you to then use to spend on business expenses, and just kind of like cycle in and out of this thing using much larger resolution and ensuring sort of the privacy, right? So you just be able to, it allows you to scale, right? And one of the things that I've personally contributed to the space actually lives in this area, and something called Scalar, which was built for the needs of the graph, which we went over briefly, but it's a decentralized indexing and query protocol. We bootstrapped that with a free service called the hosted service, just to like let people play with the technology before going fully decentralized and moving the power of indexing to other participants, and before making everything like have like governance process and verification processes around making sure that your results are correct. They would just trust us, right? But on the hosted service, we were seeing 20 billion queries per month, and that was growing exponentially. So we knew we needed something that was going to scale to a very high throughput, but also not introduce latency when serving a query. Because if you have to deal with, say, Ethereum level 1, the base chain, you're going to be waiting 14 seconds to see if a transaction is included in a block. And if you're waiting that long before your web page loads, that's like comically unacceptable, right? So we needed to not introduce latency.
Unless
but
it's
also
Google
with
Drive.
other
If
state
it's
channel
Google Drive,
systems,
14 seconds would actually be a speed up. But yes, other web services certainly would think it was bad.
Yeah. Fair enough. And so other systems that existed as well, even in the state channel space, introduced too much latency. So for example, with the Lightning Network, if you want to send a payment, you have to double sign a state, basically through all of the different routers back and forth, and before you know that payment is legitimate, and like requiring the router to even be online or to communicate with the router at all, to be able to have a consumer pay an indexer to get a query is just like, again, unacceptable, right? Because we need instant. We don't, yeah.
Well, and if I remember correctly, in the design of Lightning Network, it is also the case that it's basically a bucket brigade of time locks. So you also pay the latency at which you can actually confirm that a transaction was legitimate is directly proportional to the number of routers you went through. So the further you encapsulate the system, the more time lock contracts, they like bubble up basically. And again, I could be misrepresenting that, but that was my recollection of Lightning Network. So it actually also increases costs the more you try to actually use this system to create parallel processing. The latency gets higher and higher and higher at each time.
That's true with the Lightning Network anyway. With Scalar, we take advantage of the fact that payment typically flows in one direction, in this case, right, from consumer or from a gateway or what have you to the indexer. Or in a lot of interactions with payment in our life, I think that payment typically happens in one direction. I get paid bi-weekly, I guess, and that's like the one credit to my account, probably. And then there's 100 other outgoing payments, right? So let's take advantage of that fact.
That's a good observation too, because it seems like most people have that property. For example, a retailer typically takes money from their customers. They don't typically give money to their customers except when they're processing like a return or something, which if the retailer is going to stay in business is not the mine run of transactions. So it does seem like for many businesses, except for specific ones that maybe don't fit this profile, most people and most businesses probably do fit the criteria of there's a strong directionality to their transaction count, right? Like the number of transactions in versus out. One is very high and one's very low.
Right, absolutely. And you'd need different throughput and latency requirements on those transactions as well, especially for like retail. You want your incoming to be very fast, but if it takes a little bit longer to settle, like moving your inflow to your outflow, that's probably not a big deal for a business, right? So Scalar takes advantage of this by making payments just go one way, so that what you're giving someone is a receipt that a payment can be collected on chain in the future when they choose to, and then you can aggregate these using different techniques. Zero knowledge proofs is one of the more interesting ones that we're working on. But even without that, we can do things like stack payments on top of each other and do things like this to minimize the amount of data, and then eventually bring that on chain. They allow you also, if you put Scalar on top of something like Connect Vector, to do the collateralization and routing, so that the only interactions that you actually need to do to enable the security model are in fact very infrequent, and you can sort of withdraw money from the system or deposit is pretty much like the only thing that you need to do, like by moving inflow to outflow. So those 20 billion query fees, which are all independent and go from different participants to each other, compressed down to maybe 1,000 transactions on chain that actually need to happen, maybe like per month. So it's just something like very tiny. The speed is also pretty reasonable. Like on my laptop, I can issue about 10,000 query fees per second, because what they really are is just signed messages about a promise of payment in the future that are signed and constructed in a way that you're able to collect them. Again, taking advantage of the fact that payment flows in one direction, we can add fault tolerance to the system, which Lightning Network does not have. So if you lose state in the Lightning Network, you are just screwed, right? Someone just takes all of your money. It's kind of it's kind of hilarious, right?
Yes.
Um, except that it's terrible, so it's not hilarious at all.
Well, or they take
But
all of your
if payment,
services for free. One or the other.
right, if payment flows in one direction, though, we just make it the responsibility of the person who's holding the receipt to collect it. So if they drop that state, then they lose that one payment. And the way that payments stack, you might not even lose the payment because the person can unwittingly provide you a new version that actually included previous payments. That allows it to just function in a highly parallelized and highly fault tolerant way. We also share collateral among different channels in an interesting way, and that kind of enables more parallelism because like if you have a state channel and you're running queries, let's say that I'm asking you to serve a query and I say I'm going to promise payment for this query, and then I send it off and you haven't responded to the query yet. Now I want to make another query. What do? I don't have access to the latest implementations. They would just wait, or they would have to go through a complicated routing collateralization scheme to make a new state channel, say, which would be very expensive. Scalar does away with all that stuff, and it just says when you collateralize something, you have almost infinite lanes of parallelism. You actually have 2 to 32 lanes of parallelism, but whatever. A couple billions enough. And if a couple billions is not enough, then you can just make another. So then it's the person on the receiving end of the payment to just ensure that you are not doing double spend. We just moved that concern to the receiver, which is for a lot of applications pretty simple, right? For someone serving queries and they're primarily interacting with consumers, they just do like a lookup in memory. Have you spent more money than you have collateralized? If so, then I'm gonna stop. So that's Scalar, that's state channels, and my hope there, right, is again kind of being able to create a much more interesting internet that is not necessarily powered by ads, that I can pay for, that's not siloed and unverifiable and centralized. And if recreating the cash economy electronically is not feasible, even if we just get this, I'll be happy. That and spam calls, right? Maybe we can use Scalar for no more spam calls.
So can I ask a question? You said the phrase, in order to solve the double spend problem, I just look up in memory and see if they are collateralized. I don't quite follow that. So obviously the double spend problem is really the only problem to a certain degree that you have with digital currency, because obviously cryptographic signatures solve the problem of knowing whether or not the person actually wanted to pay you. So the primary problem is just figuring out whether they can pay you. What does it mean to look up into memory to see whether they haven't double spent?
Right. So with Scalar, you are using a different protocol underneath the hood to actually do the collateralization between participants. So in effect, a business would be collateralized by a router, and a consumer would collateralize with the router. And what you can do then is interact with the router once to open up a direct channel between the consumer and the business to be able to do different things. So from the point of view of the business, and that can be all done off chain, by the way, we don't have to bring that payment channel that exists between those two participants on chain. It can eventually get settled through the routing. So it looks a little bit kind of like the bubbling problem that you saw earlier with Lightning Network, but it's not nearly as severe, because from the point of view of each participant, only the business only cares if it's collateralized with the router. And it gets its promise of payment through the router, but not, they don't have to rely on the consumer's collateral, if that makes sense.
I don't know that it does. I mean, let me broaden the let me just broaden the question a little bit, because maybe you can just like drill down on the answer to it, which may not lie in the place that I'm asking. So, if there was an answer of the form, we just look up in memory to see if there was a double spend, wouldn't that just be the system you'd deploy? Like, you wouldn't need, if there was a system where that was efficient, why would you have a blockchain in the first place? Do you see what I'm saying?
to handle the collateralization and routing problem. So you still need to have collateralization that does this act of moving inflow to outflow periodically to kind of checkpoint the whole system and to make sure that collateral gets rebalanced.
Uh,
Right, this system cannot sustain itself in perpetuity because payment only flows in one direction.
okay. So the I think I'm missing too many parts of the system to know, because that was only like sort of a broad explanation of it, I guess. I suppose it's not super critical that I understand exactly how it works, but you said that this is the product for your company, right? Which is called Scalar.
Scalar is just a technology that we use to as a part of implementing the broader product, which is the trustless indexing and querying for public data.
Gotcha. Okay. So
it's the means of payment that we use.
And presumably I can go read up on that myself, yeah.
I think so. Yeah, I'll send more links.
Okay, excellent. Then I'll just hold off on questions because I think I would have to understand the entire thing to understand if I had an actual question about it, and it'd probably take. We've already gone for like it's almost 3 hours. So
almost 3 hours. Yeah, I've got 15 minutes left. Then I have to be somewhere else.
So let's wrap up. So was there anything that you didn't feel like we got to that you wanted to bring up in the last 15 minutes?
Well, yeah, I actually only one last point,
Okay.
which is kind of to summarize where we are at the end of the scaling thing. So if you use the state channels, right, then participants may only need to interact with the chain like biweekly. So if you have a population of 9 billion, that would require 15,000 transactions per second. I did the math earlier, whatever, you can verify it. I might be wrong, but it's around 15,000 transactions per second for everyone in the world, more than everyone in the world, to interact with the chain biweekly to move inflow to outflow, or businesses to move inflow to outflow. And then you put all these systems together, their gains are multiplicative, right? So if you have Ethereum today, which is about 14 transactions per second, I've heard the limit is actually 30, but I don't know. I see historically that 14 is about what's being used. So I'm just going to pretend that's the limit. If you have then rollups, which allow you for that amount of data to get 100 times the compute and the storage for the same amount of data, multiply those together. If you add sharding, get 64 times the data, multiply those together again, and then hand wavy about non-pessimized optimization of all of the systems involved. I'm not going to claim 100x because I think a lot of it just gets swallowed by the rollups, but let's just say 4x. You multiply those numbers together, which I don't think is entirely unreasonable, you end up with 350,000 transactions per second. And with state channels, we said we only needed 15,000 transactions per second to roughly be able to power the world's cash economy for 9 billion people. So that's an extra factor of 23 for the capacity that system could in fact handle as compared to the world's cash economy. So it gives us like some room to be wrong about the numbers that I quoted, like maybe it's not 64, maybe it's 50, maybe there's more people, or, you know, when you build a system, you understand it better. But there's like enough wiggle room there for me to be very optimistic about where the state of blockchain and scaling is going to be in 5 years, and actually even intermittently along those ways, so we kind of checkpoint these different technologies and introduce them. So I think we can actually get there, and that's my final point.
Okay. Thank you very much for taking the time today to speak with me, and I think we touched on a lot of stuff. I'm sorry you were the first person to talk about Ethereum, because it did mean that we probably had to go down a lot of exploratory places that would have been covered by someone whose interview topic was like, let me talk to you about Ethereum, which is not necessarily really what you wanted to do. So I do apologize for that, of course. But I think we got a lot of good stuff out there that we talked about anyway. So thanks for speaking with me. And could you give the folks at home who are watching this, just, where to find you, like on Twitter, or, if it's your company's website or whatever, just so they know how to, if they want to talk to you or follow you after, where they would go.
Yep. On Twitter, I'm that 3%. And start there, and then I'll respond to any requests for other contact information that are reasonable.
All right. Well, thanks so much for joining me. And yeah, if you want to do this again sometime, after I've had a chance to read about some of these other things, maybe we'll do it again.
I'd be glad to, but I'm not an expert in any of these things, so I'll try to hook you up with people who are, because I think you'll want to go in depth in all the stuff that we talked about. But thanks, it was a blast.
Awesome. Well, I would love the connections as well. Like I've said multiple times, it's difficult for me to arrange interviews if I don't have some personal invitation, because of course otherwise you're just like trying to spam people on Twitter, which rarely works. So I would love an introduction. If there's people you think I should talk to about some of the things that you were excited about, I would love to. So that would be great.
All right. Cheers.
All right. Thanks.
Thank you.
Have a good one.